Okay, we're going to try this without a pre-lesson. Section 4.3, Exponential Modeling. This right here, you guys, is really built off of what we've been talking about, a, b to the x. This one's going to be more specific, okay? Now, just so we can break this down, this right here is going to be your initial amount. Now that could be money, bacteria, whatever. But then R is your rate of increase, but there can also be decrease. So obviously if it's increase, you're going to have plus. If it's decrease, you're going to have minus. So keep that in mind. And that little rascal is time. Now something tricky happens with that in a couple of these problems, so we'll talk about that, cross that bridge when we get there. But this one right away says, tell whether the function is an exponential growth or decay. Now, we kind of talked about this in a previous thing. If b is greater than 1, you're going to have growth. If b is greater than 0 but less than 1, in other words, a fraction like 1/2 or 2/3, then it's going to be decay. Now, with that in mind, that's what they're asking us to calculate right away. Tell whether the function is exponential growth or decay. And then it says find the constant percentage rate, which is R, of growth or decay. Here's how we're going to attack this, okay? First of all, we look at this and we say, hey, that's greater than 1, so that's going to be growth. But we have to kind of tear apart this portion of the formula. If 1 plus R equals 1.025, because that's what this is, that's kind of our B right here. You see? The 1 plus R is our B. This is our A. This is our B, the stuff in here. So we take 1 plus R, set it to 1.025, and subtract 1, we get R is 0.025. Now, it does say percentage rate. So what do we got to do to convert a decimal to a percent? We got to move the decimal 2 places, so that's 2.5% growth. Okay, let's go to this one. And you can see it. This doesn't really have anything to do with the letter A. So now this one, we see that 0.95. Notice how it's less than 1. So from there, we know it's going to be decay. So the next thing we're going to do is we're going to determine what the percentage decay is. So we'd say, all right, 1 plus R equals 0.95. Subtract 1, we'd get R is equal to negative 0.05. And that equates to negative, move the decimal 2 places, 5%. This guy, well, notice that's way less than 1, barely greater than 0. So we know that's decay. And then we're going to stick with the program. 1 plus R has to equal 0.05. Subtract 1. R is negative 0.95, which translates to a negative 95% decay. All right. Now we're going to actually try some of these problems. But remember, this is your initial value, no matter what it is. Like you could go on a diet, and it's your initial weight. Or you could go on a weight gain program. It's still your initial weight, okay? This says initial height. Right there, they're saying, hey, P, that's called P naught, but they're saying this little guy, let it be 52, which is also equal to your A, okay? Increasing at a rate. So we already know from this formula, we're going to go this is equal to our initial value. We know it's increasing, so it's going to be 1 plus R. Now we got to convert this percent to a decimal, so we got to move the decimal back 2 places, 0.23, 0.23 point. And now it says per day. And so, let me pause this a second. Okay, so I was going to actually put in 1 for t, thinking it wanted us to actually calculate it, but they just want us to come up with the exponential function. So they're just going to say leave the t there. So now we have a formula, and if we want to figure out, like after 10 days, we put a 10 in there. 20 days, we put a 20 in there, etc., etc. So let's go with this one. Initial mass, 5. So I'm going to go PT equals, there's your 5 grams. That's what you're going to start out with. Decreasing, that tells you go 1 minus R. Convert that to a, see, this is 0.59%. We still have to move the decimal left 2 places, so it's 0.0059 per week. Now, keep that in mind. In this case, this would be days. This T would be weeks. See, that's going to be something you're going to have to keep track of in problems to come, okay? And when you look up Schoology, this one's probably going to be 1.023 T. And this one, you're going to go 5 equals, let me just calculate that real quick, 1 minus 0.0059. So it's 0.9941. 9941 T. I'm pretty sure that's what they'll have. Okay, so they want you to simplify it a little bit. Now, this is going to be a little interesting. This says your initial mass is 0.4 grams, so I'm going to use my formula. 0.4 grams, doubling. Now, what that means is the amount that's going to be increased is going to be, it's going to be doubled. Which means you might think of this part of the formula as increasing by 100%. So 100% is just 1. And that's really a mathematical way of just saying let your B be a 2. Because if you're going to double something, you got to multiply it by 2. So now this formula is more of one of these formulas where A is 0.4, and when they say double it, you're just saying, hey, let your B be a 2, and then you're going to go T. So that's times 2, parentheses maybe, every 5 days. So now here's a twist. If I put a T up there, I made a mistake. Because it doesn't double every day, it doubles every 5 days. So I need to put this over 5, because think about it. If I put a 5 in for T, what's 5 over 5? 1. Then I would double the amount every 5 days. So if I don't put over 5, I messed it up. Okay, so once again, this one is going to be more like that, because it says having once. We'll talk about it in a second, though. Having means a half. Here's my initial mass. So it's going to be PT equals 17 times 1/2. But I can't just put a T up there, because that would mean every hour it would cut it in half. That's not true. It's every 32 hours. So I have to put this over 32. And think about it. If this isn't making sense, put this 32 in the top. What's 32 divided by 32? 1. Then I'd have 1/2 times 17. So that's why we have to put it over 32. That's a little tricky. All right. Now this language on this side gets a little interesting, and I'm going to pause this a second coming up and explain something. But this says, example 8, the 2000 population of Las Vegas, Nevada was 478,000 and is increasing. So now watch this. This is my initial population. So here comes my formula. P of T equals 478,000 increasing, so it's going to be 1 plus See this right here? That turns into 0.0628. And so I'm going to put that right in there. And then it says each year. So when I put this T up there, I know that represents every year. Now what it says right here is it says estimate the population. And what we can actually do is calculate. See, that's a little misleading because we can do better than just estimate. We can calculate because I know what this formula needs. It says in the year 2012. Well, if it started in 2000 and it's 2012, they're saying let T equal 12. So I'm going to take this formula, 478,000. I'm going to clean up the inside here, 1.0628, and I'm going to put a 12 in there. Now I'm going to show you how to use these calculators to actually take something to the 12th power like that. I'm going to go 1.0628. Now you see that little symbol right there, that caret? That's going to be raising it to the 12th power. Now I'm going to hit enter. See, that's 2.0769. I'm going to round it a bit. Times 478,000. So I'm going to go times 478, 1, 2, 3. And so that would be 992,764.9. So probably 65, but we'll just leave it like that. Okay? Now, look at this. This problem says, in what year will the population be 1 million? Well, as you can see, we're very close to 1 million here. So why don't we just say 2013, it'll probably crack 1 million, okay? That's all we're going to do for this problem. Next one. It says the half-life, there it is again, back to this, having, so it says the half-life, so now it might be easier to remember this, because it says the half-life of a certain radioactive substance is 8 days, okay? So that formula would be f of x equals my initial amount, 15.5 grams, times 1/2, but it's every 8 days. It's not every day. So I can't just put T up there. I have to put T all over 8. Now, if you notice, it says express the amount of substance remaining as a function time T. I just did that. Okay, I did it up here. But this one says when. Now I'm going to hit pause a second. All right, so this question is out of order, and here's why. This problem, or the next lesson, 4.4 day 1, talks about logarithms, and the only way we can actually solve this problem is if we already had this lesson, and we haven't. So what we're going to do to compensate for that is this. We're going to set it up. When will there be less than 6 grams remaining? So watch this. We're going to estimate. Now I'm going to prove to you why we're going to estimate instead of solving. Interesting, up here it says estimate when we could actually calculate. Why? Because we had everything. This one, we're going to estimate and not calculate, because watch this. So here's our formula. This is saying when will there be less than 6 grams remaining? Well, I'd have to go like this. So this is saying 6. See, that's what this is. And in this formula, it would really be this. So that's what they're interested in, the amount at that particular time. So it would say 6, and we're going to go equals 15.5, and then 1/2 to the T over 8. Now, the only way we could figure this out is by using logarithms. You don't know that yet, so we're going to estimate this. And unfortunately, we're going to need part 2 of this packet lesson. See you in a second.